we're told to write the pair of numbers as a ratio, then reduce to the lowest term. So 12 to 36 can be written as 12 over 36. When we divide this by 12, remember, whatever you do to the numerator, do the same to the denominator. So when we do that, we come out with the lowest term, which in this case will be 1/3. If we want to write this fraction as a decimal, then as a percent, 7/8 is 0.875. And as a percent, you just multiply by 100 or move the decimal 2 places, you have 87.5%. To express the ratio of 10 feet to 90 inches, what we need to do is to write the values that we've been provided. To express the ratio of 10 feet to 90 inches in its lowest term, we need to make sure that the units are the same. And so when we convert this to inches, what we have is 120 inches divided by 90 inches. The units will cancel out, zeros cancel out, and what you're left with is 12/9, which is 4/3 when reduced to its lowest terms. If you want to express this as a decimal, then that would be 1.33 if we're rounding to 2 places. We looked at how to write scientific notation. So to write this in scientific notation, we move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So we have 6.26852 times 10 to the 8. To write 1.2 billion in scientific notation, that just becomes 1.2 times 10 to the 9th. Billion is 10 to the 9th when you write it in powers of 10. If we want to multiply numbers in scientific notation, we looked at how to do that. First, we want to group the like terms. So we have 9.4 times 9.5, and then we group the powers of 10. The powers of 10, since they are multiplying, we add the exponents. So this gives us 10 to the 4th. And then when we multiply this, you have 89.3. And that is the answer in scientific notation. So when you're told to round your answer to the proper scientific notation, make sure you're doing that. We can do the same here with division. Make sure you group in the like terms. We have 10 to the 7th, 10 to the 3rd. Whenever you have powers of 10, divide them, you need to subtract the exponents. So we have 10 to the 4th, and then 4.23. Now, keep in mind that we're supposed to round our answer to 1 place after the decimal. So this just becomes, and then this becomes 4.2 times 10 to the 4th. To solve proportion problems, we need to make sure that we cross multiplying. And so we have 40 times x, which is 40x. And then we have 12 times 10, which is 120. So to solve for x, divide both sides by 40. And x will be 3. We do the similar thing here. 4 times x is 4x. 7 times 12 is 84. Divide both sides by 4. X is 21. For word problems, we need to make sure that we pull in the right information from here. So 4 out of 5 students made it to class on Monday. If there are 7,500 students enrolled, how many students made it to class? So we have 4 out of 5 times 7,500 students. That gives us 6,000 students. We should also be able to use equal proportions to solve this. So by setting it up this way, dividing both sides by 5. X will be 6,000. We looked at the two ways in which we can solve percent problems. So we can either use equal proportions or we can use the equation amount is a percent of a base. So by doing that, it says, what is 15% of 90? S makes reference to the amount, of makes reference to the base, and we already know our percent. And so if we're looking for the amount, when the percent is 15, so that becomes 0.15, since we're using p%, which is the decimal equivalent, we multiply that by 90, and then X should be 13.5. Or by using equal proportions, we have amount of a base equals percent over 100. And so X over 90 will be equal to 15 over 100. Cross multiply, you have 100x. You have 90 times 15. Then you divide both sides by 100. X will be 13.5. So either using equal proportions or the equation still gives us the same answer. 210 is 25% of what number? Again, S makes reference to the amount. Again, S makes reference to the amount. We know the percent. Of makes reference to the base. So that's what we're looking for. And so setting up equal proportions, we have that. And then we can solve for X. What we get is 840. Or amount is a percent of the base. Divide both sides by 0.25. X will be 840. 1.35 will be equal to X times 7.1. Divide both sides by 7.1. X will be 0.198, which is 19.8%. Or we can use equal proportions. So amount of a base equals P over 100%. So 1.35 over 7.1 equals X over 100. Cross multiply. You find that X is 19.8% as well. It says that if there are 1.7 million homes in the United States with 330 million people, how many homes per capita? So we're told to find how many homes per capita there are. So you are looking at the ratio of the number of homes divided by the population or the number of people. So you have 7.1 million, or you can also express this as powers of 10. And then you have 330 million. So these two cancels out. So you literally have just 7.1 over 330. And that is 0.0215. Now it says we should write our answer in scientific notation. So in scientific notation, this becomes 2.15 times 10 to the minus 2. We are also told to write a sentence about what this means. Now, because we are writing meaningful sentences, you can rewrite this as a value per 100 or per 1,000. We talked about equivalent forms of numbers, so these should all be the same. And so for a meaningful sentence, we can say there are about 2 homes per 100 people. or we can say there are about 22 homes per 1,000 people. So these are some examples of how we can write meaningful sentences based on the result that we got. We have a table that shows us various ages for civilian non-institutionalized population of both sexes, male, female, expressed as numbers and as percentages. It tells us here that the numbers are in thousands. So that's an important information to consider, which means that all the numbers here have 3 extra zeros attached to it. So we're told here to calculate the ratio of males under 15 years to females under 15 years. And since we're comparing one to the other, this will be a part-to-part ratio. And so if you're looking at the ratio of under 15 years male divided by under 15 years female, then we can track that information on the table and then use that for our calculation. But because we are looking at these two ratios, then the numbers in thousands will still cancel out. Okay, so we can choose to ignore that here. So this becomes 1.05. Again, we're told to write the meaning of this value, so we can write these in its equivalent forms. So we can go for, let's say, 105 per 100. And so we can say there are we're told to calculate the dietitians per capita. What that means is that take the number of dietitians and then divide it by the population. And then we can determine the dietitians per 1,000 people. So whatever we get, just multiply by 1,000, and that should give you that amount. If the number of dietitians in Kokomo were like that of Indianapolis, what is the expected number of dietitians in Kokomo? Write a sentence about what this means. So we're setting up equal proportions here to determine the expected number of dietitians in Kokomo. So we can take the number of dietitians in Indianapolis, divide that by the population. So I'm going to keep my millions here. Again, you can always express this as powers of 10. So we have this set to be proportional to X. Since we're looking for the number of dietitians in Kokomo, we know the population is 9 million. So we can cross multiply and solve for X. So when you do the math, X becomes, and we can approximate this, since the dietitians are actually human beings, we can say that the expected number of dietitians in Kokomo will be 86,727, and that becomes the meaningful sentence. We are given the CPI table to determine if minimum wage has kept up with inflation. And so, again, setting up equal proportions, we can take the CPI value for 1972 divided by the amount in 1972 and set that to be proportional to the CPI value in 2012 divided by the amount in 2012. And so by looking at the CPI table, we can pull that information from there. 41.8 divided by 1.60, which is the minimum wage in 1972. Set that to be equal to what the CPI value is in 2012 over X. And so we cross multiply. So you have 41.8X to be equal to 1.60 times that. Divide both sides by 41.8. So X will be $8.79. So the price in 2012 was or is actually $7.25. And by adjusting for inflation, we see that this amount is more than if it has kept up with inflation. So it has surpassed the amounts that we expected it to be in 2012. We can calculate the student's GPA by using weighted averages by count. And so we can determine what the total number of counts is, and that will be 12. The total number of counts will represent the total number of credits. And since each grade has a grade number, C is a 2, A is a 4, C is a 2, and B is a 3. And so we can do 4 times 2, 4 times 4, 3 times 2, and then 1 times 3. And so we have 8, 16, 6, 3. When we add this together, we have 33. So that the student's GPA becomes 33 over 12, which is 2.75. Remember, for weighted averages by count, we take the value multiplied by count plus value times count plus value times count, and so on. And then we divide by total number of counts. And so we can calculate the student's GPA. We can also calculate the student's grade if we use weighted averages by percent. And so 75 times 0.15 is 11.25. So for weighted averages by percent, we take the value multiplied by the weight plus value times weight plus value times weight. So we can add all this together, and that gives us a student's total grade of 78.15%. We can also calculate this descriptive statistics. We need to make sure that we have arranged all these numbers in ascending order. That way, it makes it easy for us to calculate the median. And so to find the mean, we add all these numbers and then divide it by how many numbers we have. And so we have a mean or an average of 13.2. The median is the middle number when all the numbers are arranged in ascending order. And so the middle number here will be 12. The mode is the number that is most frequent in any data set. 12 appears twice, and so 12 is the mode. And our range, which is the difference between the max and the min, the max here is 18, the min is 8, and so we have 10. Finally, we'll look at how to interpret graphs. So it asks, what is unemployment rate? When we're looking at rate, we're looking at a ratio of two things with different units. And so we're looking at the ratio of the unemployed divided by the population, and that gives us the unemployment rate. So it says, how does the education level affect the rate? What we see is that the higher the educational level, the lower the rate. So when you pay close attention to the graphs that we have here, the blue represents the unemployment rate for those less than a high school diploma, 25 years and over. The red represents high school graduates, no college, 25 years and over. The green represents some college or associate degree, 25 and over. And then the purple represents college graduates, those with bachelor's degree and higher, 25 years and over. Then the lower the rate, it shows how it affects the educational level. Okay, so those that are in this region have a lower unemployment rate. And those in this region with less than a high school diploma have a higher unemployment rate. If you get a bachelor's degree and higher, then you fall into the category of low unemployment rate. Which year has the worst rate? So by looking at the year, let's say 1995, 2000, 2005, and then 2010. We see that comparing all these years, 2010 appears to be the one with the worst rates across board. So this is just a quick exam review going over all that we've covered so far in this course from sections 1 through to 6. Make sure you review the other materials that have been provided and reach out to me if you have any questions.